Hello Year 9, welcome to another exciting lesson where we get to today look at the surface area of prisms and pyramids. So we're dealing with exercise 5E in your textbook. So when we have three-dimensional shapes, as you can see a few here on the screen, each of these shapes has different sides. And if we could find the area of each side separately and add them up, that would be the total surface area, which we often just refer to as surface area. I mean, for example, if we look at this cube we know has 6 sides. We can't see them all, but they're there. So if we're finding the surface area of this cube, we have to find the area of all 6 sides. If I was to look at this prism, it's got probably, well, it's hard to tell really. It looks like it could be a square-based pyramid. It could be a triangular-based pyramid, not really sure, but it's got multiple sides. And a sphere, well, it has one side maybe. It's hard to really say how many sides a sphere has, but you've got an area around the outside, and we deal with those shapes later on. Remember, because we're dealing with area, our answers will be in units cubed, units squared. So it would be things like centimetres squared, millimetres squared, kilometres squared, and so on. So let's get into it. Let's first of all make sure we go over and understand what we're talking about when we're talking about a solid. When you're talking about surface area, you're talking about how much area is on the outside of the solid. And you can't always see all sides, so we look at this thing here, and it's called a cube. We know cubes have 6 sides. You imagine a dice. A dice has 6 sides. So what we need to do is recognize for this particular shape that we've got a front area, we've got a side area, we've got a top area, and when we look at it, we can see there's 3 sides on our shape, but we know there are 6 sides in total. When we deal with prisms and pyramids, they're a little bit different. The surface area refers to all the sides that make up the shape. And remember, possibly back in primary school when you dealt with things called nets, you actually opened up shapes to see what they looked like. Now, before we open up our shapes, let's just have a look at this rectangular prism. Well, we know it has 6 sides. We actually look at a square-based pyramid. If you look at this one, you can sort of see that there's a square on the bottom, and you've got a whole lot of triangular sides, front, back, left, and right. So that's what we're talking about when we're talking about prisms and pyramids. 3-dimensional shapes, and we've got to find the area of each side and add them together. Now, if we look at this rectangular prism, you can see that there is a front and a back, a top and a bottom, a left side and a right side. So each of these sides almost come in pairs. You could fold that out if you wanted to and make a net and then find the area of each part of the net. And you can see if you look at the net that they also come in pairs. We've got this side here that I'm highlighting and this side here, they're the same. We've got this one here and this one here are the same. And you've got those two there that are the same. You don't have to fold it out and write it as a net to be able to find the surface area. So here are some of our formulas. These formulas are quick ways to find the surface area of a rectangular prism. A quick way to find the surface area or the area of each of the 6 sides of the cube. See, there's 6 lots of the side length squared. Often I actually probably don't use 6 times L squared, to be honest, because often L's look like 1. So sometimes we call the side S and we go the surface area is equal to 6 lots of S squared rather than 6 lots of L squared, but it doesn't matter what letter you use. And we look down the bottom and we can see we've got our square-based pyramid. So find the area of the square base and then you add to that the area of the 4 triangular sides. Let's try some examples to see this in action. So the first example says to find the surface area of a cube with dimensions 3 centimetres. Well, we could draw a cube, a quick sketch of a cube. We know that all the sides are 3 centimetres. If we look at our formula sheet, we could actually go for any cube, the surface area, because there are 6 squares around the outside that are all the same, is just 6 lots of the area of one of the squares. Now, if the dimensions are 3 by 3 by 3 by 3, each square is 3 by 3, so it's 6 lots of the side squared, or 6 lots of 3 squared, because the sides are 3. 6 times 3 squared is 9, 6 nines are 54, or you could put that into your calculator, and you'll get 54 centimetres squared. Remember, this centimetre squared just means we're dealing with area. It has nothing to do with the squared there. It's just area for that part there. So there's our first example. Let's have a look at the second one. Now I'm going to do this 2 different ways. I would recommend using method 2, not method 1. Method 1 is the method we would use if we forgot or didn't know our formula. So when we look at this particular rectangular prism and we have to find the surface area of it, one thing I could focus on is the top of the rectangular prism. Now if I look at the top of this prism, I recognise it's a rectangle, and the area of a rectangle is the length times the width. So what is the area of this top rectangle? Well, there's 15 centimetres that way, 12 centimetres that way. So the length and the width is 15 and 12, or 12 and 15, it doesn't really matter which one's which. Times them together. We know the area of this top rectangle is now 180 centimetres squared. Well, why don't we focus on this green front rectangle? Now I know the area of a rectangle is length times width, and the length times the width would be 12 times 4. If you wrote 4 times 12, it would give you the same answer. The area of the green rectangle is 48 centimetres squared. Now there's one more rectangle here that I haven't dealt with that I can clearly see. So I'm going to call that the side rectangle just to give it a name. And because it's a rectangle, it's length times width. It's 15 centimetres in this direction. How high is it? It would be the same as that one there, so it's 4 centimetres high. So it would be 15 times 4, which is 60 centimetres squared. Now to find the surface area of the entire shape, we need to take these 3 answers and add them together and then double it, because I know for the top rectangle there's a similar rectangle underneath that's the same size. For the front rectangle, I know there's a rectangle hidden away at the back there. I can't see it. And I know there's a rectangle on this side here, which matches up the rectangle on the left. So I could say the total area for my shape is 2 lots of the 3 answers I got added together. And if I add them together and put that into my calculator, I get 576 square centimetres for the surface area of my entire shape. Now, as I said, method 1, it's the method I would use if I didn't recognise what the formula should be for this particular shape, or I forgot what the formula was. But let's try method 2, just using the formula that's written down in your booklet as the formula for the surface area for all rectangular prisms. It's 2 lots of length times breadth plus length times height plus breadth times height. Now this B, breadth, is sort of an old-fashioned term. L, B and H, length, breadth and height, just mean the 3 different dimensions. Doesn't matter which one's which. Let's say this one here is the height, this is the length, this is the breadth. Let's say that was the breadth, that was the height, that was the length. It doesn't matter as long as I fix them. So for this question, I'm going to call this side L, this side B, and this side H for my length, breadth, and height. And that's how I know where to put these numbers. Length times breadth is 15 times 12. And there's my 15 times 12. Plus, be careful, it's got to be a plus sign between these bits. The next part, length times height. That'll be 15 times 4. There it is there. Plus, the next part, base times height. 12 times 4, and there it is there. Plug that into your calculator, and there's your surface area. Much faster than method 1, and it's the preferred way to do rectangular prism surface area questions. So let's try example number 3 now. With example number 3, we have to find the surface area of a square-based pyramid. Well, it's telling us that the bottom of the pyramid is a square. So let's go about this process. Now, if I look at the bottom of the pyramid, and I've shaded it in a sort of a pinky type colour, there's my square on the bottom, and the area of a square I know is the side length squared, 14 times 14, or 14 squared, which is 196 millimeters squared for the area of my square base. Now, all square-based pyramids have 4 triangles around the outside that create the shape, and every triangle is the same shape. So let's focus on just one of those triangles, and I've highlighted it there in green. So it's actually, if I looked at it by itself, something like this. There's 14 down the bottom, and we're told that the distance from the top to the bottom is 9 millimeters. So that's what we've got. Well, we know the area for all triangles is a half times base times height. Well, the base is 14, and the height of my triangle is 9. So it's just a half times 14 times 9, which is 63 millimeters squared. Well, that means my total surface area is going to be the area of my square base plus 4 lots of the area of my triangle, because there are 4 triangles around the outside. So it's just 196 plus 4 lots of 63, which is 448 square millimeters. And that's how we find the surface area of square-based pyramids. Time for you to try some of the questions. Enjoy the experience, as I know you will. Bye for now.